Welcome to another edition of Red Hat Dan on Tech. It's been a while, but today recently this week, we introduced a new version of RamaLama version 0.7.0, and we've added a lot of support for it. Today, I'm going to be joined by Brian Maherbeer, and he is a software engineer at Red Hat. He's recently joined basically working on AI lab recipes and RamaLama team. And Brian led the development of RAG support inside of RamaLama. So Brian, welcome.
Thank you for having me. Yeah. Big fan of it.
Great. So what I want to talk about is, so what is RAG? So give me a quick definition of what that is.
Of course. First and foremost, big fan of the show. Glad I'm on. So yeah, RAG stands for retrieval augmented generation. It's three big words, but what RAG really means is the ability to add additional context when you're using a model to answer questions. So RAG would introduce you could have a document, and then you could the way RAG works is when you ingest the document, you're able to ask questions about the document. So that's the big overview of how RAG works.
Right. So basically, if I have a model that's been trained somewhat on the internet, but probably not going to be trained on specific data that I might have my private data or data like that, and I usually there's some kind of database. So but all my documents are in Markdown, they're in .doc formats, PDFs. So how would I take those documents and then create something that AI can actually read and interpret?
Yeah, exactly. That's the next step of what AI is for. We're giving it additional tasks without its training knowledge. So the way RAG works more technically is right now in a RamaLama RAG, we're using a application called Dockling. And what Dockling does is it uses embedding models from Hugging Face to basically convert your document PDF or HTML or whatnot into Markdown. And Dockling is special because it takes images and tables and different types of characteristics in the PDF and translates it in a way in Markdown that the model is able to understand. So it's more advanced deep learning features. So once we have that enriched Markdown, we are then going to put it in what's called a vector database. And a vector database is basically a database to hold the document information. So what happens is we take the document and we slice it up into little pieces called chunks. And we take a model called an embedding model, and we turn the words into numbers, which is a vector. And then we throw it in the vector database. So when we ask the model a question, that prompt will query the vector database and will retrieve the relevant chunks to answer the question or to potentially answer the question. And then we'll throw everything, we'll combine the context with the prompt to the model, and that's how we get our final response there.
Okay, so Dockling, I want to mention that Dockling is a project that came out of IBM, and it's really, really popular project. But Dockling it can take any random document, PDF, and basically translate it into some format that it then is easily ingested or compiled into one of these vector databases. The vector database we're going to demonstrate is actually a quadrant, right? Do you want to talk about that for a second?
Yep, exactly. Sorry, I didn't mention it, but Quadrant is the vector base of choice today. Quadrant is an open source project that is managed fairly well. It's fairly popular. It has a lot of additional features that we're utilizing here today. Some of them include hybrid search, which put simply, we're doing keyword search plus more advanced meaning search. So that's the reason why we chose Quadrant.
Okay, and basically what we built with RamaLama is all about running AI models with containers. It's taking the best parts of AI and the best parts of containers and combining it together. So what we built is we've added Dockling and Quadrant to a container image that RamaLama will pull down and actually take our PDFs and documents and compile them up into a Quadrant database. And then the last step of that is that Quadrant database. RamaLama will stick that Quadrant database into an OCI object. So basically an OCI, something that can be stored in Docker.io or Quay.io. So to give you a quick demonstration of that, fairly simple command. So this is just going to be, let me get back to the original one. So basically I'm going to take in this case, it's a simple file of the README is actually RamaLama's README, and I'm going to compile it up, and I'm going to output a container image called Quay.io, Red Hat Dan. But the interesting thing here is we're actually using AI to process the document, right? So, first Dockling is using AI to translate the document into format. And I guess what Dockling does that's really kind of cool is it actually can take, like tables and things like that and actually translate them. So it's just not just cropping the text out, it's actually interpreting the text. So while this is happening, basically it loaded up those AI models, looked at the document and translated it, and then outputted this OCI object. And if I use Podman now and looked at, Podman images, I would see that I now have a my RAG image inside Podman. So basically RamaLama in the background is using Podman. It could have used Docker, but of course I'm the Podman guy, so we use that. So now I have this, data. Now I need to associate that with my document. But I didn't find that one all that interesting, but I wanted to do my book. So to give you a quick example, running AI models. So what I'm going to do is just run the regular AI model on my system, and then I'm going to ask it some questions and just see how well it knows about, Podman in Action, my book. So I'm going to run RamaLama on it. Granted, one cool thing that we've added to RamaLama is actually we show the engine here, so you see a little sail. So that's kind of cute. If you ran it with Docker, you'd see a whale there. But anyways, I think that's kind of cute. But if I ask it who wrote Podman in Action, of course, it answers it correctly this time. We're going to cut this section. We're going to do it again. So let's get out. Let's just do it with this one.
Yeah.
So basically, I'm going to run a Granite model, and I'm going to ask it a question about Podman in Action and see how good an answer I get out of it. So it's kind of cool here that we have this little logos that we put into it to tell you what the underlying engine you're running. In this case, we're running with Podman, and you can see the little Podman sail. And if you were running with Docker, you'd probably see a Docker whale. So now I'm going to ask it who wrote Podman in Action. And it comes up and it says it was written by Jeff Phillips and Dan Walsh. I don't really know who Jeff Phillips is, but he gets the major billing on this. And, it talks about me a little bit, but, I really want to take full credit for writing it. So, and I want to ask it other questions about Podman in Action. So what I previously did here is I actually, ran that RAG command that we saw earlier, and I created a images, and call Podman in Action using the previously ran it through there. It takes about 10 minutes to run it through, but it actually came from my book, which is a Podman in Action book that I have locally. So I ran it through there, and now I'm going to actually run a similar test but this time I'm going to use instead of running the RamaLama command directly, I'm going to run it with a RAG option. So this RAG option is basically going to pull down that model. So if that model was stored up at Quay, it would pull it down to the local system and then mount it into the container. And this is the container that you and I worked on that's going to do processing of it. So at this point, we'll run it, and then we'll talk a little bit about what's going on inside the container when we run this.
Yep.
So right now, it's actually reading the database, reading the thing into memory, and now I'm ready to ask questions. Wrote and action. I get full credit. So that's, to me, a lot more satisfying with my UG go. But anyways, that's kind of an easy question to ask it. But let's ask it a more complicated question that you would only, wouldn't it be gathered by a random thing? Who did the author dedicate the book to?
Well, we have to cut that out. That's funny.
Yeah, we're gonna cut out another part.
We almost had it. Oh well.
We'll start it again. Okay. So basically, I had the book on disk, and I pre-compiled it into the image. Now I'm going to run it with the model again on the system. And basically this time, if that model was stored at Quay.io, start it one more time.
Yeah. Okay.
So we pre-compiled the image, the Podman in action into a document, and now I'm going to run it inside of my container. But this time, instead of just running it native, we've added a new command, a new option to the RamaLama run command and the RAG option. And what RAG will do is go out. This will cause RamaLama to go out and see if the image is stored locally, or if Podman in action image is not stored locally, it'll go out to Quay and actually pull it down, just like it would pull down any image from the system, and then it will mount it into the container in such a way that we can use it. After we do this demonstration, I want you to explain to me what happens underneath the covers. So let's do a quick demonstration on it. Right now, it's loading the model into memory as well as the database and connecting them together. Now I'm going to ask a question: who wrote Podman in action? And it answers correctly. Doesn't give credit to some other random dude on the internet. Gave it all to me, which satisfies my huge ego. But really, what I want to do is I want to ask it, other questions that you would only get from actually being inside the book or really understanding what's going on in the book. So I'm going to ask, who did the author dedicate the book to?
Well, that's it. Wait, why is it not working? I guess this always happens when we want to actually do something. Okay, let's try it one more time. But before we cut to the next part, why don't you try instead of saying who wrote Podman in action, just say who is the author of Podman in action. Maybe that might solve something.
This worked perfectly. It started recording.
I know, right?
Okay, so we're going to run, basically now we can use the new Podman command, new RamaLama command, and this command has a new option, --rag. So when I do RamaLama run, instead of just running the model locally, I'm going to actually give it the RAG database, and the RAG database has a pre-compiled Podman in action book inside of it. And what I'm going to do at this point is I'm going to ask it a question about who is the author of Podman in action. We're waiting while it loads everything into memory. And it gives me a nice, satisfying answer and tells me that, I am the author of Podman in Action. But I want to ask it a more specific question to, that might not be able to just glean off the internet, but really would have to understand the book. So it says, which college? Walsh go to? See if it can answer that question. And it did. It went to basically figured out I got a BA from College of the Holy Cross. Now I'll ask it, who did the author dedicate the book to? And in fact, it basically understands that I dedicated the book to my mother. So what basically, we're proving that all this information that you wouldn't have in a standard Granite model is now available because I've associated the PDF, basically the compiled PDF to the model, and it's able to go in and look at that database. So what's going on under the covers? How did what is the cool feature? How come this works now?
Yeah, exactly. This has been a great demo. So what's going under the covers really is when we're prompting who's the author of Podman in Action, we're first querying the vector database, and it's getting a few chunks. Now the chunks don't have the actual answer written out, but it has parts of the book that's actually being forwarded to the model. So you have the prompt plus the context, and the model will basically take the context and figure out the answer based on that context. Now this is really cool because RamaLama has, we could pull multiple models down. So it's fun to test which model works. Here we're using Granite 3.2. So the better the model, the better the output is for RAG, as we can see here. One thing I really wanted to emphasize on is the last prompt here, is that who did the author dedicate the book to? Now, what's really cool here is that we're not using Dan Walsh's name here, and we're not referencing the book by name. We're just saying book, and we're saying author. And the model is able to understand from the previous context we have that Dan Walsh is the author, and the book is Podman in Action. And then it takes that and then queries the vector database to get the relevant information for the answer. So as you're playing around with RAG, it becomes a little smarter because I'm actually inputting the chat history along with querying the vector database.
Cool. So this basically demonstrates that some of the powers of Podman Action, some of the powers of AI, and really what our goal here is to get this simple. So imagine you could set up basically have a huge amount of documents, and you want to process it. And basically, you could continuously process your documents, recreate your RAG database, push your RAG database out to a registry, and then basically start to really start building an app. So potentially, I might want to build an app, basically called it Podman in Actions model, or Podman in Action server, where you could basically come and talk to a AI model and do it. So what I might do to make that happen now is I want to convert that model into an OCI object. I want to have an OCI object for my RAG database for Podman in Action, and now I want to create a RAG database, a model as an OCI object. And what I'm going to do here is I'm going to do the RamaLama convert to create it. Now this can take a decent amount of time. So rather than going through the demonstration of this right now, I previously did this with a Granite model. So if I do Podman images, you'll see that I have Granite already converted to the system. So I actually have an AP object, but here, this example, I'm going to use this. So now I'm going to go back to our previously demo. And instead of using Granite 3B here, I'm going to actually use an OCI object. So I'm going to put this in to it. So basically now I'm using 2 OCI objects. I have the OCI, basically actually using 3, because underneath the covers I'm using the tool that's running the AI is also in a container image. So what I'm going to do here is I'm going to show you actually what's happening underneath the covers by you running a dry run command. So if you look here now, you see a massive run command, Podman run command. And this is really what's going on under the covers. And if I look through this, I start to see some of the, different tools that we're using in here. But I want to show you quickly that underneath the covers, I'm running this container image. So this is the container image that actually has Llama CPP in it, quay.io/RamaLama/CUDA. Since I'm running on an NVIDIA laptop, NVIDIA-based laptop, I'm pulling down the CUDA library in it. But I'm also mounting up images into the container. So here I am doing the Podman in Action book. You see that here. So that's being mounted. That's the OCI content being mounted into the container. And then I'm also using the actual model, the granite model. So I'm using 3 different OCI contents in it to put together this application that I'm demonstrating. But the really cool thing is, if I wanted to put this into production, I actually have another command, another serve command that I could run, and to basically run this as a service, and then I could do a conversion. So I want to generate a let's clear the screen right now. I want to generate, say, a cube object out of this. So this went out and generated a Kubernetes YAML file now that I can go and look at. And this puts together, here's the Llama command that I would run, the application in. I also can show the different models that I'm mounting down here. So it says I'm going to mount the models into the container. And here I'm mounting the Granite model. And then I'm also going to mount in separately the Podman in Action book. So basically, I could actually run this as a service inside of something like OpenShift at this point, and actually run a service. Similarly, I could, use a Quadlet to put this thing into production. So the bottom line here is, RamaLama is a tool that we're trying to put together so people can experiment with models, but basically start to look at things like generating RAG, and then really get to the point where they can put the things in production, or at least give them scripts that can help understand how they would put something in production. Last thing I want to say about this, the really cool thing about the Kubernetes YAML file, or if I generate the Quadlets for this, I'm not going to use RamaLama inside of these Quadlets or inside of the Kubernetes YAML file. I'm not actually having to run that tool there. The tool generated the container, documentation how to run it. So bottom line is, we got a great job here putting together a way of compiling up random documents, putting them into OCI content, and then being able to run OCI content as RAG along with an AI model, and then finally be able to put them into production. Yeah. So kind of demonstrates it. So you got any last comments?
Yeah, I did. I mean, this you summarized it perfectly, but I just wanted to add, this for RamaLama, we're all about using containers, and this RAG feature that we have is basically, turning the vector database in containers. And as Dan showed, it's going to be easy to use for production. So, later on for RAG, we could even drag and drop other RAG frameworks or other vector databases. And we can use RamaLama to basically a one-way street for production. So it's really cool, and I'm seeing where the vision is going.
Yeah, so I think that we're always looking for contributors. Right now we picked a Quadrant, but we're open to it seems like everybody in the universe has their own favorite vector database or RAG vector database. So we'd be looking at if other people want to contribute other ones or come to it. But basically, we're looking for ideas and how we can go forward with this. But great job, and thanks for joining us this week.
Thank you.